Hello, hi, namaskar everyone. Just give me a quick update in the comments. Am I clearly visible and audible? Everyone, just give me a quick response. Are you all there? Were you all notified about this class which got all of a sudden planned? Yes, so I'm hoping that some of you are there. Nobody is responding yet. So are you all there? Were you all notified about this extra class which got planned? Okay, somebody is showering love. I'm sure that you all were notified. You got a notification timely and you got the time to prepare for this class. Prepare means you got ready with this class, right? I hope you know that today there was a public holiday and I took the advantage of that public holiday. I was told that there is a holiday, so I got to know that there are no classes in the evening today, so I got this extra session planned. And with this extra session, we'll get this entire chapter covered with this one class. So I'm intending to finish this chapter. This is going to be again one of those amazing classes where we'll be concluding the chapter matrices and determinants. So good morning, everyone. Good morning. Good to have you all. Brilliant. I repeat, listen to this part very carefully. This is your final chunk of the chapter matrices and determinants. And today we'll be covering matrix, polynomial, characteristic equations, eigenvalues, and a lot more. The final part where this chapter gets concluded and from where most of the questions are asked by JEE Mains in advance. So we'll be learning every single detail in a very crystal clear manner, and I'll be hoping that you also participate, interact, and ask whatever doubts, queries, and concerns you have. Shall we get started? Now, before I get started, I hope you know so far we have discussed all these things. There is no confusion regarding formation, algebra, and even types and trace and product of matrices. Not just that, different types of matrices, skew, symmetric, symmetric, transpose, adjoint, its properties, inverse. We have covered everything so far. And now this is the last chunk of this chapter, which we'll be covering today. Good morning, everyone. Good morning. Good morning. Good to have you all. I hope I'm clearly visible and audible and you all can hear me and see me properly, and it's going great. I think the number of participants are a little less because of the sudden plan which we have brought for you. So I'll keep it simple. You'll be seeing a lot of questions coming in between, but rather I'll be skipping all those questions. First of all, I'll deliberately take you through the entire theory. I'll make you understand the whole theory first, and then we'll start doing questions. Will that be okay? Of course, in between, you'll be seeing a lot of questions, but I'll intentionally skip those questions. But later on, once the whole theory gets completed, I'll start coming back and then we'll start from scratch from the question number 1 and we'll do all the questions. I hope you got the agenda, you got the flow, and you have this clarity that why is this session so important for you all. Okay, so shall we get started with that? Keep responding, keep interacting, whatever concerns and queries you have, I'll be really happy in addressing all of them. So first of all, what we know is that, sir, if there is a polynomial, so how do we write a polynomial? I hope you know this completely clearly, that let's say there is a polynomial or a quadratic polynomial, a second degree polynomial. So one of the examples of a second degree polynomial could be this: x square minus 3x plus 2. This is a quadratic polynomial. If I wish to write a cubic polynomial in x, I can write that, yes or no? So that's how you define polynomials in variable x. But sir, you are stating that if we are talking about a topic matrix polynomial, so you are wanting to say that polynomials exist for matrices as well. Yes, they do. And the beauty here is that a lot of problems asked by IIT-JEE Mains and Advanced can look amazingly lengthy and time consuming, but they can be done very efficiently, effectively by you, and you can handle them very easily if you know this concept. So that's the beauty of it. A lot of people refrain from adapting it. A lot of people stay away from it. The only reason they give is that, sir, this is a higher level topic which we should not touch, which we should not study. Will unnecessarily get confused. Trust me, you will not. This is not a higher level topic or a concept. Trust me, this is that tool, this is that weapon if you carry or have with yourself. Trust me, there are a lot of questions which you can do very effectively, very efficiently, and very easily. So I hope you are getting the agenda or the point of today's discussion or today's topic. And with this, we'll be concluding this chapter. So the final nail in the coffin. So with that here, if I am given a polynomial, I hope you understand polynomials. This is a polynomial of degree m, cubic, quadratic. So usually you will be restricted to cubic only because in your syllabus or as per your syllabus, we will be dealing with either a 3 by 3 or a 2 by 2 by 2 square matrix. So if it is 3 by 3 square matrix, you will be dealing with a cubic polynomial, matrix polynomial. If it is a 2 by 2 matrix, you will be dealing with a quadratic polynomial. That's the beauty. So if you wish to write the matrix polynomial for a matrix, and if it is a 3 by 3 square matrix, it will be giving you a cubic matrix polynomial. If it is a 2 by 2 square matrix, and if you wish to write its matrix polynomial, you will be getting a quadratic polynomial. Whatever I've said so far, is that understood by everyone? I hope there is no confusion on that. There will be a lot of facts which I'll be simply spitting, and I'll be assuming that you just accept them. A lot of things I'll be just saying, and I may not be giving you a lot of logical reasons behind them. And right now at this stage, I'll be expecting and hoping that you just digest, accept and absorb that. Gradually, when the session unfolds, you will automatically start getting them. You'll automatically start understanding the logic behind them. Everything will come layer by layer. So have patience. Don't get restless. Just with a lot of patience, just keep watching this session, and whatever doubts or concerns you have, just keep them posted. I'll be really happy in addressing them. But if something which needs to be addressed later, I'll skip that query or concern. Will that be okay? So matrix polynomial, if you are dealing with a 3 by 3, it looks like a binomial. No, colic. It's simply a polynomial. So if you have a 3 by 3 square matrix, you will be getting a cubic matrix polynomial. If it is a 2 by 2 square matrix, you want to write its matrix polynomial, it will be a quadratic. Did you all get that? Now, with this, let's say f of x is what? A quadratic polynomial. So let's say I want to write a matrix A there is, which is a square 2 by 2 matrix, and for its matrix polynomial equation, let's say, is given by this a square minus 7a plus 32. Let's say this here, it should be I2. This should be I2. I'm really sorry for this. So this is a matrix polynomial, just one of the ways of writing polynomials. But instead of variable x, what we are having here is a matrix. And I hope you remember, in the world of matrices, we don't have a scalar quantity. Actually, we should multiply that scalar with an identity so that matrices can be added, subtracted, or multiplied. Did you all get that? So far from this slide, is there any confusion? Are you clear with this? If I were to make you solve this question, this will give you more better clarity. Let me try and help you with this question. What are we told? And if you are already there, actively willing to participate, shall we not conduct a poll along with the solution which I am giving to you? So you can also start solving this question with me. This is a very simple, straightforward, direct question asked by JEE Mains. You won't believe that JEE Mains asks you such simple, straightforward, decent, crystal clear questions if you just know the basics. What do I mean by that? Everybody listening and understanding, all the participants. How many students do we have today? May I know the attendance? 1, 2, 3, 4, 5. Can you write in the comments quickly, everyone? So what am I told? A is a 3 by 3. Okay. Real matrix such that this fulfills this condition. So whenever a matrix equation is given, I would treat it as a matrix polynomial. Right? How will I do that? Pay attention on this. I will simplify this as a square into a, that is a cube, a square into minus 2i, that is 2, a square I, this is minus 4a, and this is plus 4. Correct me if I'm wrong. I repeat, a cube minus 2a square minus 4a plus 4i. Of course, I should also be there, so I'll just put an I here because 4 scalar cannot stay alone there. 1, 2, 3, 4. Okay, if somebody rewrites it, then give me the number, update that number. So here comes this cubic matrix polynomial. What does it mean? It means that here it is a 3 by 3. So of course it is supposed to be a 3-degree matrix polynomial. I hope that part is easily understood by everyone. Then what happens is, of course, we are clearly told that I and O, as per the convention, we also know this, are identity and your null matrices. Now, I am told that there is one more matrix polynomial, which is a to the power 5 alpha a square plus beta a plus gamma I, where alpha, beta, gamma are real constant. Then they are asking you the value of alpha plus beta plus gamma. Now, how do we find that out? I'll tell you, just look at this expression. Sir, can I not write a cube as, pay attention to this, 2a square plus 4a minus 4i. If I shift this whole part to the other side, and when it is added to the null, it gets added like this. Okay, so I think somewhere around 6 to 8 students. That's good. Good to have you all. I really appreciate the spirit. Now with this, I hope you are paying attention to this part, everyone. This is a cube. Sir, what do we need? We need a to the power 5. So in order to have a to the power 5, what do I need? Sir, instead of directly reaching towards a to the power 5, which you can definitely do, can I multiply it by a once? When you multiply it by a once, you get a to the power 4. And again, if you multiply it by a one more time, you'll get a to the power 5. So you have two choices. Either you directly multiply a square on both the sides, or what you do is you multiply it by a once. The agenda here is if I directly multiply it by a square, I'll get a to the power 4 here. But I don't have any expression as of now in terms of a to the power 4. Although we can create, that is perfectly doable. So that choice you always have. So let's say I multiply both the sides by a square. So if I'm doing that, I'll get a square into a cube, that is a to the power 5. A square is 2 into a to the power 4. This is 4a cube, yes or no? And this is minus 4a square. Got this point, everyone? Everyone comfortably got this. Now, two things I'm willing to substitute here. One thing, I hope you're understanding, a square I'm okay with. So in a to the power 5, I'll be witnessing a square, but in a to the power 5, a to the power 4 and a cube, these terms won't be there. Okay, so let's try and make them vanish. So first of all, let me work on creating a to the power 4. So from here, can I develop a to the power 4? What would that be? So if I multiply a on both the sides, it will become a to the power 4. What will it become? So this will become 2a cube. This will become 4a square. This will become 4a square. And what will it become? It will become minus 4a. Yes or no? Yes or no? Everybody give me a quick response. Let's say you wish to simplify it further. So you can go ahead with one more step. So what is that one more step? You could have simply done one more idea or one more implementation here, that this a cube you can substitute by this value. So why are we doing this? Because I'm seeing something really interesting here. That's very good observation, Jagrati. So a cube, when this particular a cube is substituted by this value, a to the power 4, we receive as 2 times a cube. What is a cube? That is this. Sir, this is 2a square plus 4a minus 4i. Yes or no? Plus 4a square minus 4a. Yes or no? Everybody got that? Or shall I re-explain that? Everybody, give me a quick confirmation. All I'm saying is a cube got replaced by 2a square plus 4a minus 4i. Double of it plus 4a square minus 4a. Yes or no? Everybody with me? Now, if I simplify this, what do I get? Sir, we get a to the power 4 as 2 into 2. 4a square plus 4a square, that is 8a square. Yes or no? Then pay attention to this. 2 into 4, 8a minus 4a, that is plus 4a. Then of course 2 into 4, that is minus 8i. So that is a to the power 4 in terms of a square. Got my point, everyone? So there, when I'm willing to write a to the power 5, will I not be writing it as 2a to the power 4? So 2 when multiplied to this, 2 when multiplied to this gives you what? 2 into 8, that is 16a square. Yes or no? 2 into 4, that is 8a. And then 8 into 2, that is minus 16i. Correct me if I'm wrong in terms of any calculation. Plus, minus, or any number which I mistakenly write something else as, please correct me. This is your 2a to the power 4. But now I'm supposed to write 4a cube. Sir, what will be 4a cube? A cube is this. This is a cube. So if I multiply it by 4, I'll get 4 into 2, 8. So this will be 8a square. Then 4 into 4, that is 16a. Yes or no? Then 4 into 4, that is again minus 16i. Yes or no, everyone? So 2a to the power 4, 4a cube I have written. Now I'm supposed to write 4a square, which will be simply 4a square only. I think your job is now left to simplifying this expression, which you all can do quite easily. You all are really good at doing that, I believe so, because with that final simplification, you will get the answer. Yes or no, everyone? So far, everybody is with me. So far, have you all been able to digest whatever is said so far? So I think this will give me the final value, which will be a to the power 5. What does it look like? Sir, let's talk about the terms with a square. So this is 16a square, 8a square and 4a square. So that is 16 plus 4. I think it is 20a square. Correct me if I'm wrong. So this will be 20a square. 16 plus 4, right? With this, terms with a. Terms with a are 8 and 16. Yes or no? 8 and 16. Correct me if I'm wrong. 8 and 16. Yes or no? So I hope nothing is left. So 8 plus 16 is 24. So this gives you 24a. Then I think terms with identity are 16 and 16. That's minus 32. So this is minus 32 identity matrix. So this is how your e to the power 5 looks like. Correct me if I'm wrong. I hope this is exactly how it will look like. I think we do have the answer at our fingertips now, because if I compare it with this, alpha will be 20, beta will be 24, and gamma will be minus 32. Alpha plus beta plus gamma, so your answer will be 20 plus 24 minus 32. How much is that? This is 44, yes or no? So 44 minus 32 is clearly 12, which means option A. Brilliant. And I'm sure everybody must have marked option A by now. Let's quickly see how many of you got an option A. 77%. Jagriti, Dhanu, Kolik, Sanjana, Muskan, Dakshit, Naglakshmi. That's brilliant. Some of you got option B and D as well. Why? Why? Any calculation based error, or what mistake did you commit? Have you all understood how do we deal with simple matrix polynomial based questions? Did you all get this, or shall I re-explain any part of this question? All the participants. Everybody understood that? Now with this, let us move ahead and get more clarity on matrix polynomial. Sir, what is the advantage of having a matrix polynomial? What is the point of having a matrix polynomial? Why are we doing this? Okay, let me give you a simple example here. Let's say there is a matrix polynomial which is given by a square minus 3a plus I is equal to null matrix. Let's say without even giving that matrix A, or without even finding a lot of information about that matrix A, I know that there is a matrix polynomial which this matrix A satisfies, which luckily happens to be a quadratic in our case right now. So if this is a quadratic matrix polynomial, I get this notion or idea that this will definitely be a 2 by 2 matrix, square matrix, yes or no? Now if I rearrange it, sir, what do you mean by rearranging it? If I take this to the other side, will I not have I as 3a minus a square, yes or no? Sir, what if you multiply it by A inverse on both these sides? So if I'm multiplying by A inverse on both these sides, it will be A inverse. 3A, A inverse will be 3I, and this will be A. So that's the beauty of having, that's the advantage of having matrix polynomial. One of the advantages I'm saying, which means, let's say I had a matrix polynomial, I rearranged it, and after rearranging it, I got the inverse of it. So I did not have to invest my time in figuring out its adjoint, its dividing it by determinant of A and then finding its inverse. I could simply do nothing but identity matrix multiplied by 3, and then you subtract the original matrix. Luckily, you will get the inverse of it. Isn't it more simpler and beautiful? You know how to operate on it, don't you? So I hope you all are realizing it will be more simpler and easier. Everybody getting the idea that one of the benefits of having matrix polynomial is finding its inverse very quickly. Everybody got that logic? That's exactly what is written over here. I hope it is self-explanatory now. Everybody got that. This is exactly what is written over here. Now, matrix polynomial was given by, of course, Cayley-Hamilton. Some people call it Lewis-Hamilton. So they also give you the same idea. I'll give you one more example here. Let's say there is a cubic, let's say 3a cube. Or rather, let me write it a more simple version. Let's say here I'm given a cube minus 3a square plus, let's say, 6a minus 2i is equal to null matrix. Of course, it is a cubic one. Cubic one means what? It will be a 3 by 3 square matrix. So if I wish to find its inverse, there is one more method. One of the methods is finding the inverse with the standard method. But if I'm already given the matrix polynomial, that means a polynomial equation which matrix A satisfies, then I'll say that this can be rearranged and rewritten as this whole part taken to the other side except for 2i. Getting it, everyone? So there I'll be writing it as 2i is equal to this whole expression, which will be negative of a cube. I'm really sorry. This whole I keep here, 2i I take there. So 2i will be a cube minus 3a square plus 6a. Yes or no? Now, one thing I'll do, I can multiply it by 1 by 2 on both these sides. 1 by 2 is a scalar. So if I'm multiplying it by 1 by 2 on both these sides, it will look like this. Yes or no? Now, to find the inverse here, all I'm going to do is a very simple observation that here I'll multiply both the sides by A inverse. I'm assuming that A is an invertible matrix. A is a non-singular matrix. So if I multiply it by A inverse on both the sides, what do I get? A inverse I'll receive as A inverse into A cube. That leaves you with A square. Getting it or not, everyone? Then 3A square into A inverse, that is 3A. Yes or no, everyone? Then you have 6A inverse into A, that is 6 identity matrix. And if you just find the value of this expression, that will also give you the inverse of A. tell me honestly, are you all digesting this comfortably? Are you all able to comprehend this interesting concept here, matrix polynomial, Cayley-Hamilton method, or what they came up with? Sir, why are we studying this? Why are we discussing this? What is the point of doing all of this? Is it really important to study this? How is it going to be beneficial? Let's get more clarity with one more example. So here we go with another question for the day. Shall we start this? Everybody. I'm sure most of you can do it with that short technique which we have already discussed while we were talking about inverse of a matrix. Somebody must have already started applying that. But if you haven't, let me tell you a standard method here. Then I'll tell you the shorter method as well. And then I'll tell you, or I'll ask you, which method will you prefer? Okay. So with this, I'll say this is your matrix A. So what Cayley-Hamilton suggested was that if there is a matrix A, then for any matrix A, I hope you remember, it satisfies A minus lambda I determinant to be 0. Sir, what are you trying to say? It is absolutely non-understandable. We are not getting this. Okay, so let me tell you the whole proof first, which we have already luckily discussed previously. But if you have not seen that, if you have forgotten that, or if you're watching it for the first time, let me show it to you. Always remember, I'll show you the proof first, then I'll get back to that question. Will that be okay? So here we are. We know that for any matrix A, there exists a non-zero matrix A which exists in such a manner that AX is lambda X. This is what suggested by Cayley-Hamilton. What did they say? I repeat, that there is always a non-zero matrix X. Matrices are treated as vectors as well, so don't get confused by the language. Just pay attention to what I'm going to say next. So there is X, which is a non-zero. Non-zero means non-null. It is not null. So there is X, a non-null matrix, which is always going to be there, which will always exist in such a manner that when you multiply a matrix A with X, it will give you lambda X. This is what they discovered. This is what they figured. This is what they stated. So what is the point or advantage of this? I'll say if I take lambda X on the left hand side, so what will I have? I'll have AX minus lambda X is equal to null matrix. So A is pre-multiplied on both these sides. Sorry, X is post-multiplied on both these sides. So if I take that X common, can I not write it as A minus lambda I X is equal to null matrix? Now, the beautiful thing here is, the most interesting thing here which I'm going to do here is that A minus lambda I X, its determinant will be determinant of null matrix. And what is the determinant of null matrix? Sir, we know determinant of null matrix is 0. Determinant of null matrix is 0. And we know determinant can be splitted over product of matrices. Yes or no? So I can write it as determinant of A minus lambda I times determinant of X as 0. But what did we start? What did we start our discussion with? How did we start our discussion with? I said that there is a matrix X which is non-zero, non-null. So we know that its determinant cannot be 0. Are you getting it? So if its determinant cannot be 0, or if its determinant is not supposed to be 0, I hope you're realizing what is supposed to be 0 then. This is non-null, so this has to be 0. So what Cayley-Hamilton came up with was that they said that A minus lambda I is definitely going to be singular, which means determinant of A minus lambda I is bound to be 0, which means for any matrix A, there exists a scalar lambda such that A minus lambda I will be singular, which means A minus lambda I's determinant will be 0. Give me a quick thumbs up in the chat box if you have gotten this final verdict or statement which I have just given. I repeat this line. For any matrix A, there will always exist a scalar lambda such that A minus lambda I will be singular, which means A minus lambda I determinant will be 0. Tell me in the comment box. Did you all, or were you all able to digest this final verdict which I have just given? In the comment box quickly, everyone, all the participants. Have you all been able to digest this statement? Did you all get that? All the participants, be quick. Now, if you have gotten that conclusion which I have just given, let me get back to this question which we were supposed to get started with. let me apply the Cayley-Hamilton method here, which they came up with was what? So they suggested that for any matrix A, there will exist a scalar lambda. I think there is already a lambda, so I'll introduce some other variable here. Let me introduce some other variable x, such that A minus xi determinant, you can say k or x or l or m or a, whatever you wish to, but you're supposed to take one thing. So this will always be true. For any matrix A, there exists a scalar such that A minus xi determinant will be 0. Did you all get that statement? By using Cayley-Hamilton only. So by using this, what will I say here? This is your first method, right? This is your first method or first way of solving this question. I will show you one more method of solving this question, which most of you must have already thought of because we have already discussed that method when we were discussing inverse of a matrix. Do you remember that, everybody? So there, this is A. What is A? Sir, A is 1, 5, lambda, 10. So 1, 5, lambda, 10. Yes or no? Sir, what is xi? Sir, xi will be x into I. So x 0, 0x, 1, 0, 0, 1 is your I. So x when multiplied gives you this. And its determinant, this difference determinant will be 0. Yes or no? So this will be 1 minus x. This you should not write in two steps. This you can write directly. But since you are doing it for the first time, I'm writing it in a more clearer manner. This is 5 minus 0, which is 5. This is lambda minus 0, which is lambda. And this is 10 minus x. So this is what you should be able to write in one step only. You should not invest your time in writing this time and again. Everyone comfortably got this, all the participants. Now what I do is, I'll simplify this. So how do I simplify this? I'll say, I hope you know the expansion of a 2 by 2 determinant. So that if I use here, I'll get my final answer. 1 minus x, 10 minus x. So this is 1 minus x into 10 minus x minus 5 lambda. And this value is given as what? 0. Everybody got that? Now, if I write its matrix polynomial, it will be given by what? X into x, that is x square, 10x, I hope you're listening, 10x, and then this x, I'm really sorry, minus 10x minus x. So that gives you minus 11x, yes or no? Then the next thing which we get is, I hope you're listening, 10. So the next term will be 10 minus 5 lambda. Don't get confused, this is not that lambda, this is x here. That's good, Jagrati. I'm glad that you worked it out. So this will be x squared, then minus 10x minus x minus 11x, and then you'll be left with the constant term 10 minus 5 lambda, which is 0. So here the variable is x. And this matrix A will satisfy this polynomial. So if I wish to write the matrix polynomial for A, how will I write it, everybody? It will be written as a square minus 11a plus 10 minus 5 lambda, yes or no, is equal to null matrix, and there it should be multiplied with an identity matrix. So this, I am rewriting it, 10 minus 5 lambda times I. I hope you're getting it. If I wish to write its matrix polynomial, a square minus 11a, 10 minus 5 lambda I is equal to null. Did you all get that? Everybody, give me a quick confirmation. Sir, they are not asking you this. Rather, they are asking you that A inverse is given by alpha A plus beta I. Okay. So A inverse is given by alpha A plus beta I. Okay. So here, with this, can I define A inverse? Although, sir, instead of doing all of this, you would have simply adapted one more method which we know. What is? Find A inverse. That is also a very good method. But I'm deliberately stopping myself from using that because we have already used those methods previously. So now I'm deliberately wanting to use matrix polynomial, Cayley-Hamilton. I hope you're getting that. Everybody understood that? There is third method as well, which I have just told you, that you can simply find its inverse, compare it with this equation and find alpha, beta and lambda. That is also a doable approach here, which you can do. But I am, apart from that, trying to tell you two other methods. Everybody listening and understanding that, all the participants. Now with this, pay attention to this part, all the participants. Here, if I take this a square and 11a to the other side, I'll have 10 minus 5 lambda I is equal to minus a square plus 11a, yes or no? And if I divide both the sides by 10 minus 5 lambda, I hope you're realizing what will I get? I'll get I as minus a square divided by 10 minus 5 lambda. So can I write it as minus 1 by 10 minus 5 lambda, yes or no, plus 11 by 10 minus 5 lambda, yes or no, everyone? times A. Everybody got this? But sir, we are not interested in I, we are interested in A inverse. So one more thing I should have done in this step only directly, and I could have reached to that third step only by skipping these two steps. But since we are doing it for the first time, I'm doing it step by step, but you don't have to do it, right? So if I multiply it by A inverse on both these sides, what do I get? Can I write it directly here at this stage? So here, this will be your A inverse. This A square into A inverse will leave you with A, and this A into A inverse will leave you with I. So this is what you get. So what we get is A inverse as something into A plus something into I. But what am I given in the question, sir? I am given A inverse as something into A plus something into I. Yes, that's correct. So I think I have alpha and beta both. Are you not thinking that, sir, this here is nothing but alpha and this here is nothing but beta? These are your alpha and beta. These are your alpha and beta. Everybody getting this? So now if I use this data or use this information, what is alpha and what is beta? They. And alpha plus beta. So this is alpha, which is minus 1 upon what? 10 minus 5 lambda. What is beta? Sir, beta is 11 upon 10 minus 5 lambda, and alpha plus beta is given to be minus 2. Everybody listening and understanding that? With that, I think I do have my final answer now. Why? Because 10 minus 5 lambda, 10 minus 5 lambda is pushed there. So 11 minus 1 is 10 is equal to minus 2 into 10 minus 5 lambda. Yes or no? So minus 2 when divides this 10, it leaves you with a minus 5 here. So this is a minus 5 here. So 10 when comes here, it becomes minus 15. So minus 15 is minus 5 lambda. So lambda we receive as 3. Yes or no? Give me a quick update. Everybody got that? So if I've gotten lambda as 3, I think I can crack alpha and beta both. So from here, alpha will be cracked as what is 3, right? So 5 into 3 is 15. Yes or no? So 10 minus 15 is what? 10 minus 15 is, I hope we are going right. Lambda is 3, so 3, 15. 10 minus 15 is minus 5. Minus 1 by minus 5 is 1 by 5. So alpha we receive as 1 by 5. What about beta here, students? Beta is again 11 by 10 minus 5 lambda. So lambda is again 3. 5 into 3, 15 minus 5. So this is 11 by minus 5. So I can write it as minus 11 by 5. Everybody getting that? Then we are asked 4 alpha square plus beta square plus gamma square. That we can predict very easily. 4 alpha square. So 4 into alpha square means what? 4 alpha square is 1 by 25. Beta square, that is 11 square by 25. That is 121 by 25. Correct me if I'm wrong. 11 square is 121. And then lambda square, which is 3 square, which is 9. So 9 when multiplied by 25 gives you this. Yes or no? And 9 times of 25 is what? 9 times of lambda is 3. Yes, lambda is 3. I hope I have taken the correct value. So 25 into 9 is what? 250 minus 25. That is 225. So this I write as 225. Everybody getting that? Everybody getting that? So this leaves me what? This leaves me with what? 121 plus 4 is 125. I should have kept it as, okay, let me do it now anyways. Rather, if I keep it as 9 by 25 only, 9 by 5 only, will that be okay? Rather, what was it? This was lambda square is 9. So I'll keep it as 9 only. Is that okay? So this is what? 125 by 25. This is 125 by 25. Yes or no? And do we know what is it? Sir, we know this is 5 times of it. So 5 means what? 5. 5 means 5. So 9 plus 5 gives you what? 14. That gives you option C as the correct answer. I think this was not a 2023 PYQ, this was the 2026 PYQ. As far as I recall it, we have already done it. When we were conducting the analysis, when paper got released, we were discussing these questions. So I do remember this was supposed to be 2026 PYQ. So this is having your answer as option C, and I'm hoping that's brilliant. That's very good. 90% of the people. So Winter, Dhanu, Harini, Jagriti, Dakshit, Muskan, Kaulik, Sanjana, Rajshekhar, everybody. Who is this 10%? Who got it wrong? Now, sir, you promised us that you will share one more approach, another approach. Yes, I told you. So what would that be? Okay, let's talk about that only. I'll talk about that second approach here only. Will that be okay? So, sir, what do you mean by that second approach? Yes, let me discuss that now. Pay attention to that. Will I not say that in this question, you could have directly written its matrix polynomial or characteristic equation? Do you remember that? How do we do that? Do you remember that short technique? Anyone? Can somebody write in the comments that if there is a 2 by 2, there is a 2 by 2 Then for a 2 by 2 matrix, you know how to find its matrix polynomial by using that shortcut. I hope you do remember for a 2 by 2, look at this 10 plus 1, 11 and 10 minus 5 lambda, the determinant, yes or no. So I hope you remember if there is a 2 by 2 matrix, you write its matrix polynomial by a square minus trace of a into a plus determinant of a into I is equal to null matrix. This is that short technique which you can always use directly instead of investing your time in developing it. So I think we did 2 to 3 steps there which could have been skipped by you and you could have directly written this. I hope you are clearly realizing what is a square. Sir, a square is a square. What is trace of a? Trace of a is 1 plus 10, 11, but negative of it. Then, what is determinant of a? Determinant of a is 10 minus 5 lambda. So instead of doing that whole thing, a minus xi, its determinant null, then you replace x by a, then finally you do all of this. No, you don't have to do this. You could have directly written this, yes or no. Do you all remember this short technique? And by having this again, you can apply the same process again and could have gotten the answer. So this is your second method, which I'm saying should be used by you, which will definitely save a lot of time of yours. So I hope so far, whatever we have discussed is very directly and easily understood by everyone. Shall I move ahead from here? I hope no confusion on that. So we all know this conclusion that if there is a square matrix, then a minus lambda a is equal to 0 is going to give you the characteristic equation. And every matrix satisfies its characteristic equation. So far, this is what we have discussed. Everybody with me on this? And for example, if I solve it for a 3 by 3 matrix by solving a minus lambda I determinant 0, I'll get a cubic polynomial in lambda. And that lambda can be replaced by a, because what is this? A minus ai. What is a minus ai? A minus a. A minus a is what? Null. So determinant of null is 0. So they did not say something out of the box, but it did wonders in the world of matrices. It did something really amazing in the world of matrices. So I hope you are realizing how beautiful this is, how interesting and simple it is. Simple yet very powerful. Simple yet very, 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 helpful. So now I will introduce one more terminology, which is called eigenvalue. Why, sir? First of all, let me tell you what is it, then I'll tell you why and how and properties and everything I'll tell you. Don't worry about that. And the applications and the usefulness of it, I'll make you explore every single thing. But right now, first of all, let's understand that let's say I converted this matrix, I got this matrix A's characteristic equation and that I got as lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. Let's say I got this. And when I solve this, let's say when I solve this, of course, I'll start getting the values of lambda. So since it is cubic, I'll get 3 values of lambda. Let's say lambda 1, lambda 2 and lambda 3. So these are the 3 values of this cubic equation in the variable lambda. So lambda 1, lambda 2, lambda 3, these 3 values which I'm going to get are called the eigenvalues of this matrix A. Those who are getting confused that, sir, you told in the beginning that a matrix is simply an arrangement of rows and columns. It does not have any value. But if there is a square matrix, its determinant has a value. So of course, right now also I'm not saying that the matrix A has values lambda 1, lambda 2, lambda 3. No, I did not say so. But if you are assuming it, then you are assuming it incorrectly. What I'm saying here is that if there is a matrix polynomial where this A, first of all, was taken as a variable lambda, and if you solve this polynomial, you will get certain values of lambda if it is cubic 3, if it is quadratic 2, and those values will be said or will be called the eigenvalues, which means lambda 1, lambda 2, lambda 3 are not the value of A. A is a matrix. It's an arrangement. But if I ask you the eigenvalues of A, they are called lambda 1, lambda 2, lambda 3. Sir, why are we doing this? I'll tell you that. But so far, whatever I've said, is that understood by everyone? Shall I move ahead from here, all the participants? Everyone comfortable with whatever is said so far? Give me a quick update, everyone. Now, pay attention to this. The beauty of eigenvalues of A here is that it helps you in solving a lot of complicated, integrated and lengthy problems in a very quicker manner. I'll demonstrate one of the examples here right there in front of you. Let's say I solved this. I found a lambda. which means eigenvalues of A. And with that, if I got eigenvalues of A, eigenvalues of A inverse will be lambda inverse. Sir, first of all, why are we finding this eigenvalue? How will it be useful? You are straight away telling us the properties there. What is the need of doing this? Can you help with that first? No. In the beginning of this session only, I told you, have patience. Things will start unfolding one after another, layer by layer. So you got to have a lot of patience in today's session. But once all of this gets culminated, you will be able to connect the dots. But right now, the future is uncertain. Just have patience, wait and watch. Let everything get unfold. Get my point, everyone? Getting my point, everyone? So, all I'm saying is, let's say someday, I am asked in a question, let's say, to deal with the eigenvalues of A inverse. But what I know is the eigenvalues of A. Let's say eigenvalues of A are 3, 4, 5. But in our question, let's say I need the eigenvalues of A inverse. So the beauty of eigenvalues of A inverse will be, it will be reciprocal of the eigenvalues of A. 1 by 2, 1 by 3, 1 by 5. Sir, we will accept all what you are saying, whatever you are saying that A inverse has its eigenvalues as 1 by lambda. We got all of this, but why are we doing this? As I have already told you, please have patience. Right now, just start accepting things as the way are. You will very soon realize how helpful and how beautiful and how wonderful they are. But have patience. Everybody with me so far? Everybody just quickly give me a thumbs up. So far, whatever I've said, is that understood by everyone? Can I move ahead from here, all the participants? Give me a quick update. So I hope eigenvalues, are you comfortable with this? Are you all comfortable with this? Let's say there is a matrix which satisfies this matrix polynomial, which means it was given as a square minus 5a plus 6i is equal to null matrix. So this was that matrix polynomial. So if it satisfies this matrix polynomial, of course, it was originally lambda square minus 5 lambda plus 6. So if you are solving this, I hope you are realizing you will get what? Lambda as 2 and 3, yes or no? So I will say here that matrix A has two eigenvalues. Matrix has two eigenvalues, which are what? Which are 2 and 3. Now, shall I start telling you a lot of beautiful things? Will that be okay? Will you be able to digest and absorb all of that? So if I begin with the first statement of mine, I'll say the first statement of mine is what I have already said so far, that if I ask you the eigenvalues of A inverse, then we know it will be reciprocal of the eigenvalues of A. So they were 2 and 3. So its eigenvalues will be, I hope you're realizing, 1 by 2 and 1 by 3. Let's say I ask you the eigenvalues of A to the power 1000. If I ask you the eigenvalues of A to the power 1000, so it will be 2 to the power 1000 and 3 to the power 1000, which means, I hope you're now understanding the concept of eigenvalues. It will be 2 to the power 1000 and 3 to the power 1000. Let's say I ask you the eigenvalues. Let's say, what is happening? Let's say I ask you the eigenvalues of 5 into A. Let's say I ask you the eigenvalues of a scalar into A. Are you getting it? So the eigenvalues of a scalar into A will be that scalar into eigenvalues of A. Listening and understanding, that means 5 into 2, 10. I hope you are understanding. And 5 into 3, 15. So first of all, these are the major properties of eigenvalues. Let me give a better explanation here. Let me take you to that slide only first, then I'll come back to this. So I think we have the eigenvalues here. I'll take you through these one after another. I hope everyone is patiently understanding and watching it. So first of all, any square matrix A and its transpose will always have the same eigenvalues. What does it mean? If there is a matrix A and I found its eigenvalues. Sir, how do we find the eigenvalues? By writing its matrix polynomial and solving it. I'll get values because it will be satisfying certain values. Those will be the roots or solutions of that matrix polynomial or polynomial, and those eigenvalues will be same for its transpose as well. So let's say in a question, you are asked the eigenvalues of transpose of a matrix. So let's say you need it. then you wouldn't waste your time in finding it, because you know this property that a matrix and its transpose have the same eigenvalues. I'll tell you, Moktika, I told you in the beginning of this session, I'll be doing more of the theory first, and then I'll be sharing the examples. And when I start doing the examples, you will see them getting applied. So I have kept the questions in today's session where I'll be showing you these properties getting applied. But as I have already requested everybody that have patience. This comment was anyway supposed to be there, and that's great that you are asking it. That means you are trying to understand it. And I know the kind of complexity it is creating here today, because you are asked to learn a lot of theory and then apply it. But trust me, it will be worth doing it. It will be worth watching it. Have patience. Now the second part. This is the most beautiful part. Sum of the eigenvalues of a matrix is always equal to the trace of the matrix. And I hope you are able to digest that statement. Why is it true? I hope you're getting this logic very clearly. If there is lambda cube minus, let's say, 3 lambda square plus, let's say what? Plus, let's say 5 lambda plus, let's say 6 is equal to 0. So this is what? Sum of the roots taken one at a time, yes or no? So this is always given by lambda 1 plus lambda 2 plus lambda 3, yes or no? So minus 3 here is what? Sum of the roots. Sum of the roots means what? Sum of the eigenvalues. Do you know that? But always remember the short trick which we have discussed for creating the characteristic equation of a matrix. It is always giving you that here you will always write trace of that matrix into that matrix raised to the power n minus 1. So if it is cubic, it will be 2. If it is a 2 by 2, it will be 1 here, power 1 here. But this will always be trace of A here. So everybody got my point that here, this minus 3 means what? This minus 3 means what? I hope you're getting it. So I hope this part is logically also understood by you all, that here, sum of the eigenvalues of a matrix is always equal to the trace of the matrix. If you still got confused, I'll take one more example of a square. Let's say there is 2 lambda square minus 6 lambda plus, let's say, 5 is equal to null matrix. So there, this minus 6 is nothing but what? Sum of the roots, which is what? Lambda 1 plus lambda 2. But as per the short technique, what we know? First of all, I got to divide it by 2 because I want to keep this coefficient 1 here. So if I divide it by 2, it will become what? Let me write this as the equation. So let's say the matrix polynomial of a 2 by 2 matrix is lambda square minus 6 lambda plus 5. So what I know is that this minus 6 is nothing but what? Sum of the roots lambda 1 plus lambda 2. What is it? Product of the roots. But forget that. I am more interested in the sum of the roots. So, but the short technique says, sir, here it is determinant of A, yes or no, with the negative sign. Sorry. This is determinant of A. What is it? This is trace of A, yes or no? So I hope you got this idea very clearly that sum of the eigenvalues is always equal to the trace of the matrix. Did you all get that? Or shall I repeat it, all the participants? I hope everybody is comfortably understanding that this plus 6 is your sum of eigenvalues, which is trace of the matrix. This plus 3 here is sum of the eigenvalues lambda 1, lambda 2, lambda 3, which is the trace of your matrix. Are you all getting this or not? Tell me honestly. Or is it getting confusing? Tell me honestly. Plus minus will keep coming. Plus minus will keep coming. Alternatively, that's different case, which we'll discuss as a short technique. But have you all been able to digest this simple statement that for any matrix, if you see its matrix polynomial, and if you're solving that, you will get eigenvalues, and sum of those eigenvalues will always be equal to the trace of that matrix. Sir, why are we learning this? I am giving you, let's say someday, we are not given a matrix in a question, and we are asked the trace of that matrix. But what we know is its characteristic equation. So by looking at that characteristic equation, I will be finding the sum of the eigenvalues, the sum of the roots, and that sum of the roots will be equal to the trace of the matrix. The job will be done within 10 seconds and you will get the answer, yes or no. So first of all, it's really important that you understand these properties, and I'll show you how do we apply them. But let's learn these properties first. Is that okay? Now, moving ahead with this, the next conclusion will be product of the eigenvalues. So product of the eigenvalues is always equal to the determinant of that matrix. Is it not understandable again? Because as we have just learned that short technique, let me show you that short technique again. I hope you remember this constant term here is always giving you what? Determinant of that matrix. But in our world, what is it? It is the product of those eigenvalues. This constant term here is representing you what? Determinant of that matrix. But in our world, we know this is the product of those roots. Some of the roots, product of the roots. I hope you know that. Some of the roots taken 1 at a time, some of the roots taken 2 at a time, some of the roots taken 3 at a time. I hope you know that basic funda, yes or no. I hope that logic is giving you a sufficient reason to believe that yes, it will be true that some of the eigenvalues will be trace and product of the eigenvalues will be the determinant. What is the meaning of this? Let's say in a question, you are given a 10 by 10 matrix, which means you're not given that matrix, you're asked its values. But let's say the question, instead of giving you the whole 10 by 10 matrix, asking you its determinant, is not giving you the whole 10 by 10 matrix, but it is giving you its 10 eigenvalues. Can I now not find the value of that 10 by 10 matrix determinant? We know that determinant of any matrix is always equal to the product of its eigenvalues. So if I know those 10 values only, I'll simply multiply them and I'll tell that this is the determinant of it. Will it not be absolutely easy, simple and doable? When you know these properties? Yes or no? Are you learning these properties, the three most important properties here? Have you gotten a decent clarity on all these three properties? Yes or no? Tell me honestly. Everybody got that? I hope it is not getting very heavy. You are able to digest and understand all what is being said, everyone. With this, I hope this is what you have already understood. Let's say there is an n by n matrix, 3 by 3 or 2 by 2. So if it is n by n, it will have n eigenvalues. If it is 3 by 3, it will have 3 eigenvalues. If it is 2 by 2, it will have 2 eigenvalues. So any matrix which is k, a scalar into that matrix, it will have eigenvalues as k lambda 1, k lambda 2, k lambda 3 and so on. If you are finding a to the power m, its eigenvalues will be, there is a correction here, there is a correction here, there is a small correction here, it should be lambda n to the power m. So a to the power m will have eigenvalues as lambda 1 to the power m, lambda 2 to the power n, lambda 3 to the power m and so on. Sir, A inverse will have its eigenvalues as 1 by lambda 1, 1 by lambda 2 and so on. So tell me honestly, have you all understood these three properties which I have already explored or told you or explained you in the previous slide as well? So I think I need not invest my time on doing that. So far, whatever is said, understood by everyone, or shall I re-explain? This is one of the most important slides which you should keep with you. Please don't forget this. This is going to be very useful, very, very, very useful. Shall I move ahead from here? Shall I go back to the discussion we all were having? Now, if we have discussed eigenvalues, what are their applications? That's exactly what we'll now start exploring. But before I start exploring, I am hoping and assuming this is what you already know, because this is what we have discussed when we were discussing inverse of a matrix. I told you this short technique, rather a lot of you already told me, and I'm really glad that you know a lot of things. That really relieves me. So with this, if there is a 2 by 2 matrix, then characteristic equation of this matrix can be given by determinant of A minus lambda is equal to 0. But to save your time, what you can directly use is lambda square minus S1 lambda plus S2. So what is S1? S1 is always the sum of the leading diagonal elements, which in our language is called to be the trace of that matrix. And what is S2? S2 is always the determinant of that matrix. So if I were to simplify this for you, I'll say for any matrix A, its characteristic equation will be given by A square minus trace of A times A, because it will be scalar, plus determinant of A times I, because this will be again a scalar, is equal to 0, is equal to null. So this is how you write the characteristic equation of a 2 by 2 matrix. Will you all remember this short technique, the working rule, or you may call it short technique? Everybody got this? Shall we quickly take an example just to get clarity on that? For example, let's say I give you a matrix 2, 3, 4, minus 1. Can you quickly write its characteristic equation? What would that be? Anyone? Be quick. I hope everybody must have worked it out now. First of all, sir, if let's say this is a matrix B, so its characteristic equation will be given by B square minus trace of B. Trace of B means 2 minus 1, that is 1. So 1 into B, that is B, plus, plus minus plus. Please remember that sign scheme. So plus minus plus. Determinant of B. Determinant of B is minus 2 minus 7. I hope you're getting it. Minus 2, sorry. Minus 2 minus 12. So minus 2 minus 12 is how much? Minus 14. So plus of minus 14 is minus 14. So this should be minus 14 identity matrix is equal to null matrix. Simple, isn't it? Beautiful, isn't it? Straightforward, isn't it? How many of you could crack it within 5 seconds? How many of you are able to do it? Everybody give me a quick thumbs up if you have understood the standard working rule which we'll be following for writing the characteristic equation of a 2 by 2 matrix. Have you all gotten a decent clarity on that? Give me a quick confirmation, students. And if you all have gotten a decent clarity on that, I think so far all the questions are done by us. Let's put our focus on the next question here. We'll be doing a question first, then I'll talk about a 3 by 3. So this is a question which I think is a good question. Let's solve this. Can somebody help me with this question? Archana is finally asking us, sir, matrix polynomial and characteristic equation are same. Archana, why? why do you guys do this to me? Always. I am in the flow, in the middle of something, when I am in my complete, excitement and enthusiasm, in my complete flow, in my full rhythm, I'm explaining you something very beautifully, and you come up with something so exciting. Great. Are you, Archana, what should I say this? Yes, they are same. Why? I started my discussion with the same idea. Did I not start my... I came up with this matrix polynomial. This is matrix polynomial, and this is called the characteristic equation. I must have mentioned it somewhere. Did I not do it? Or have I forgotten doing it? I think so. So far, were you calling them or treating them different, Archana? And how are you able to understand all of this? So Cayley-Hamilton characteristic equation and this all is same. Whatever we are doing it. So people give them different names. I'll say whatever their names are, it doesn't matter. You should understand the approach. So Cayley-Hamilton characteristic equation, but I'm really glad you asked it. I'm really glad you asked it. Let people laugh. Of course, I shouldn't. As a teacher of yours, I definitely should not, but I'm really sorry. But I'm glad you asked. And don't refrain from asking your doubts, no matter how silly it sounds to others. Even I in my life have asked such terrible doubts that everybody around laughed at me. Even after asking that doubt, I sometimes realized that how silly or stupid it was. But it is fine. I got my doubt cleared. That's more important. It is always good to ask questions. It does not cost you anything. Please remember that. And it really helps me a lot in life. No matter how silly my questions are, but if I ask questions, I don't go ahead with that doubt. And I always stay assured. So I have this very good habit of mine. Let me tell you that. Let's say if I'm traveling, let's say if I'm going out, let's say if I'm purchasing something, let's say if I'm moving somewhere, let's say if I'm the garden or park, let's say I'm playing with my daughter or playing with other kids, I always ask questions. I don't go ahead with the doubt. So that iota of doubt, if there is with you, remove that. Don't carry it with you. It's a very good thing, Archana. It's a very good habit of yours. No matter how silly your doubts are, ask them. Let people think of whatever they want to think of you. That's their job. You keep your doubts clarified. And I'm glad you asked it, because now finally we are clear that you will be treating all of this as same one single topic, matrix polynomial or characteristic equation, or even Cayley-Hamilton. Archana, Cayley-Hamilton method is also the same, characteristic equation or matrix polynomial only. So the person who is constantly laughing, is it the same guy who constantly laughs in our class? Or is it some other person? Do we have that renowned personality with us finally? The one who is constantly laughing? Or is it a ghost of him? So if I now, Archana, I hope you are not offended by my remarks and you will keep asking your doubts the way you asked. Don't ever feel like, hesitating to ask your doubts. Never hesitate in asking your doubts, please. Everybody take care of it, right? Now, this is, I think, was the question we were supposed to solve. But Archana, you asked it very late. You could have asked it earlier. Shouldn't you? Okay, we'll be solving this question now. Good. This is the same. I think someday some other person also asked us something interesting, right? What was that? I think there was something that, sir, explain what is that orthogonal matrix. So I was about to complete the whole discussion of orthogonal matrix, and in the end, somebody asked me, sir, what is orthogonal matrix? Who was that? I think it was Adesh that day. So Jagrati is very busy in finding her answers. That's brilliant. Good, Harini. And I'm hoping that other was also just like that, only focused. That's the kind of spirit we want and expect from you all. So let's start or get started with this question. Let's call it again a poll kind of a question, integer type. Timeless poll will be conducting. So let's see how many of you get this. So let's begin with this. A is a 2 by 2 real matrix. Okay. The most beautiful thing in our life can happen is somebody gives us a 2 by 2 because things become really simple and absolutely doable. And identity matrix of order 2. So I is identity. If the roots of equation A minus xi, the moment somebody says this, are they not telling you the eigenvalues? So if you know the concept of eigenvalues, you don't have to get confused with this idea A minus xi determinant is null, then roots of it. They are unnecessarily confusing you, yes or no. But isn't it really simple for you now that, sir, I hope, Archana, you're listening, A minus xi determinant is null. This is not, this is 0. So this means what? I'll be getting the characteristic equation or matrix polynomial of the matrix A with this. Yes or no? Give me an update on that. So that matrix polynomial which will be created, I don't know that. I'm not given that. But that matrix polynomial will have two roots. So let's say that matrix polynomial I'm writing in terms of x here. It is not lambda here. So that will be a quadratic. That matrix polynomial, that characteristic equation here of this matrix A, which is a 2 by 2, will be a quadratic. So if it is a quadratic here, I hope you're realizing that has two eigenvalues. Which two eigenvalues, students? -1 and 3, because they are the roots of that equation. So if they are the roots of that equation, the roots are -1 and 3. So if I know the two roots of an equation, I hope we know how to write the equation. Yes or no? I hope you remember x square minus sum of the roots into x plus product of the roots is equal to 0. Yes or no? X square minus alpha plus beta into x plus alpha into beta. That is all what you know from theory of equations, from quadratic equations. Yes or no? Yes, it looks easy now. It looks easy now. It will look easy now. Why would it not look easy? So if I simplify this, it will be x square minus what? 3 minus 1, 2. So this is minus 2x and minus 3 is equal to 0. This is your matrix polynomial, but in terms of x. If I simply replace x by a, although you don't have to do all of this, you could have gotten the answer within seconds, but I'm doing it. So to clarify things to you, you don't have to do all of this. Absolutely not. Just read the question, your job will be done. But I'm doing all of this just to make you understand things more clearly, the concept of matrix polynomial more clearly. So here I'll be writing it as a square minus 2a minus 3 is equal to null, minus 3i is equal to null. So that is the characteristic equation or matrix polynomial of matrix A. Archana. And everybody else who was treating matrix polynomial and characteristic equation as two different entities. Everybody else, please take care of this thing. Now, sir, are we really asked this? Why did you not read the whole question? First of all, read the whole question. What are we asked? Check it out. So if I read the whole question, I am told sum of the diagonal elements. I think if you know the concept of eigenvalues, you know the answer already, don't you? Sir, sum of the diagonal matrix of matrix A, had that been asked, my answer would have been 2. Sorry, my answer would have been 2. Yes, because sum of the eigenvalues is equal to trace of the matrix A. So my answer would have been 3 minus 1. 3 plus minus 1, that is 2. And my job will be done. But I think they are asking you a different question. They are asking you sum of the diagonal elements of the matrix A square. Now you tell me, don't you think so that if you know those properties which we have just learnt about eigenvalues, will it not be absolutely useful to apply in this question and get the answer very quickly? A lot of people say that I teach this topic unnecessarily to the students. A lot of people have told me that, sir, you complicate this chapter unnecessarily with the introduction of Cayley-Hamilton matrix polynomial or eigenvalues or those properties which I have just discussed. Was it really irrelevant? Is it not absolutely useful that you could get the answer to this question within 5 to 10 seconds if you know these properties. So if you invest your time here in this 1 to 2 hour lecture, learning characteristic equation, matrix polynomial or Cayley-Hamilton, will you not be able to do these questions asked by JEE Mains very quickly? That's my whole point. Everybody got that? So here am I asked sum of the diagonal matrix of A square. Sir, A square, if A has eigenvalues as -1 and 3, what is the property? Sir, A square will have its eigenvalues as -1 square and 3 square, yes or no? So -1 square is 1, 3 square is 9, yes or no? So the eigenvalues of A square will be 1 and 9, but that is not what we are asked. As somebody, I think Jagrati has wrote in the comments that, sir, we are asked sum of the diagonal elements of A square. Sum of the diagonal elements of A square, which means trace of A square. So trace of any matrix, I hope you remember, is nothing but sum of its eigenvalues. So trace of any matrix is always equal to sum of its eigenvalues, yes or no? Do we not know this property? And if I apply that, my answer is right there in front of me. That will be 1 plus 9. Answer will be 10. Yes or no? Yes or no? And I don't have to do all of this, really. I could have done it after this only. That, sir, this has eigenvalues as -1 and 3. A square will have eigenvalues as 1 and 9. Sum of the diagonal elements, trace, means sum of the eigenvalues, 1 plus 9 is 10. I could have done it mentally. A question asked by JEE Mains could be done on your fingertips. You don't have to write anything at all. Why did I write all of this? Just to make you understand this concept, just to be more clear with that. I hope everybody got this. Let's see how many of you comfortably got, I think 10 is the answer, right? So let's see how many of you got 10 as the answer. Okay, 90% is a really good number. That helps me in understanding that you have started understanding it. Harini, Krupa, Dhanu. Today I am able to believe that 2 seconds is an acceptable remark here. Yes, but still I'll say 2 seconds it takes for somebody to read a question. At least 5 to 10 seconds you take. You're doing it in 2 seconds. How unbelievable. Harini and Krupa, how are you doing it? Even 11 seconds, Dhanu and Sanjana. I think up to 26 seconds it is an acceptable data. But before that, it is really unbelievable. 12 seconds you took, Sanjana, and you did it. Are you really honestly doing it in 12 seconds? Tell me honestly. Then we have Naglakshmi, Kolik, Jagrati, and Dakshit. And then we have Archana. Archana, great. So Archana finally did it. Great. I'm really proud of you, everyone. And there is one more candidate. We have Adipu, Shelja. Great. Good. So everybody got this? Easy question. Yes, it was easy, Kolik. So easy peasy, yes or no? Let us move ahead with the next question. With that, let me move ahead with one more data here, then I'll talk about the next question. Now, for 2 by 2 things are really simple, but for 3 by 3 things are a little intricated. They are a little complicated. How? Let's say if there is a 3 by 3 and you want to write its characteristic equation. Then of course, sign scheme plus minus you follow alternatively. Lambda cube, lambda square, lambda, and then constant. But with them, the coefficients are S1, S2, and S3. Sir, what are these S1, S2, and S3? Let's talk about them. So S1 here is again nothing but sum of your leading diagonal elements, which in our language we treated as trace of A. Okay, Krupa, I get it now. Okay, I get it. Okay. Archana's doubt. People are explicitly taking Archana's name today. Archana is today's celebrity. Archana is the celebrity of our class today. Okay, so next statement is sum of the minors. Where was I? I lost the track of the class. I was explaining you the characteristic equation, the matrix polynomial of a 3 by 3. So I told you S1, sum of the leading diagonal, which is trace in our language. What is S2? I'll explain that later. I'm skipping it right now. Let me talk about S3 first. What is S3? S3 is always your determinant. So I repeat, this entry will always be trace. This entry will always be your determinant. Now, meanwhile, in between, what happens is you define S2. So there are 2 ways of doing it. There are always 2 ways of doing it. What are 2 ways? First way, Archana, I hope you're not offended by our discussion today. There are always 2 ways. First way, you simply write a minus lambda I, you find its determinant, you put it equal to 0, and then you write its matrix polynomial or characteristic equation. But let's say I don't want to invest my time in doing that. I can write it directly with a cube minus trace of a into a square plus something into a, that's something I'll explain, minus determinant of a. Now, what is that something? What is that S2? Can you explain that, sir? Yes, that S2 is very beautiful thing here, but it will take some time for you to resolve or work it out. That S2 is the sum of the minors of the principal diagonal elements. What did you just say, sir? I said that the minor of A11. What is the minor of A11? This minus this. So this is your minor of A11. What is minor of A22? Sir, minor of A22 will be, I hope you know, this minus this. Everybody understanding my language? Sir, what is the minor of A33? Minor of A33 will be, I hope you remember, this minus this. So if you find the minors of these leading diagonal elements, principal diagonal elements, if you add them up, you will find, of course, minor means certain values, you will finally get the value S2. So everybody got S1, S2, S3. Shall I take an example to make you understand all of this? First of all, let me do that so that you don't get confused and you have this thing with yourself. So let's say there is a matrix A, which is a 3 by 3 matrix. Some really simple values I'll take: 1, minus 1, 0, 2, 1, 3, and then 1, 2, and let's say minus 2. Are you okay with that? Are you okay with that, everyone? Now, to write its characteristic equation, there are two ways. What are two ways? You write A minus lambda I and you find its determinant, which is 0. What is A? This is A. What is lambda I? Lambda 0, 0. 0 lambda 0, 0 0 lambda. So that you subtract from it, you find its determinant, you will definitely get a cubic in lambda, and that when you simplify, that will be the characteristic equation or matrix polynomial of your matrix A. That is one of the methods. That is one of the methods. Somebody has again leaked, I think, NO. NO is the gas, right? Nitrogen oxide, which makes you all laugh. Am I correct? You all know chemistry better than me, so tell me, what is called the laughing gas? So here, sir, I don't want to use that method, although it is going to take same amount of time. Either you use A minus lambda I or the method which I am suggesting to you to do. So there, I'll write its matrix polynomial as A square minus plus minus sum of the principal diagonal elements, that is trace of it. So 1 plus 1, 2, 2 minus 2, that is 0. So it will be 0 into A. Sorry, it's not A square, I'm really sorry. It is cubic, A cube minus. So I'll take rather it as some other value so that you don't miss anything. So let me write it in minus 1 is, are you okay with that? So 1 minus 1, 0, 0 minus 2 is minus 2. So it will be minus of minus 2 plus 2A square. Yes or no? This is your S1. Everybody getting that comfortably, all the participants. Then what you do is S2. That S2 I'm skipping right now. I'm not writing it. And then I'm writing S3. I'm writing S3. Is that okay? So S3 into identity matrix. What is that S3? Sir, S3, how long that class is? We started at 11. This is supposed to be an extra class. And as I've already mentioned, extra classes are supposed to be lengthy. Should I not take the benefit here? You don't have any classes in the evening today. So shall I not stretch it till, let's say, 2 o'clock at least? I hope no one is offended by that remark. Yes, I'll be taking it till 2 o'clock today at least. I want to complete this completely. And if I'm in the flow, if you are also in the flow, if you're understanding it, let's cover it. Are you all with me, everyone? If you need a break, tell me. If you are fed up, tell me. We'll take a break, but we'll resume again. But I want to complete it in one sprint. I don't want to stretch it unnecessarily for another session where you lose your focus, momentum, and then we have to build it again. No. Then again, someday you ask me, are they same or different? So here we are. Let me take its determinant here. So it is 1, minus 1, 0. Then you have 2, minus 1, 3. Then you have 1, 2, minus 2. Yes or no, everyone? Then how do we find its determinant? It will be, I'm using Kramer's rule, 1, minus 1, 0. Sorry, Sarah's rule. There are a lot of mathematicians, even I get confused. So 1 minus 1 0, 2 minus 1 3. So I have taken all the rows correctly. Yes. So 1 minus 2 2, that is 2. This is 0. I hope writing it correctly. This is minus 3. Then from this, if I subtract, this is 0, this is 6, and this is, I think, 4. Correct me if I'm wrong. So this is 10, this is minus 1. Minus 1 minus 10 is minus 11. So your determinant of A is minus 11. Determinant of A here is minus 11. So that S3 here is minus 11. So this will be minus of minus 11. Everybody understood that? Don't tell me 2 is impossible. Everything is possible. You are at such an early stage of your preparation and you're talking like that. Don't do that. Don't give me those reasons. You can. You all can. You have better capabilities than that. Trust me, you have better potential than that. You can do a lot of things. It's just a barrier which you have in your brain that you cannot. Trust me. If I talk about the potential you have, trust me, you can do wonders in your life. It's merely nothing what you're asking for. Trust me. I will be taking it till 2 o'clock. If you really want to understand and study this, which will definitely help you in getting some amazing marks from this chapter, where we are concluding this chapter, all what the efforts which we have put so far on matrices and determinants, do you want all it to go in vain? Do you want all it to be wasted? If the momentum is built, why are you not utilizing it? You are in your flow, you are understanding everything, and now you want to give up, you want to quit. Come on, don't do that. It's like you're just before the finishing line quitting. Don't do that, please. You have infinite potential, trust me. It's just there in your brain. It's just there in your mind. That barrier, that block. No, we will continue. Don't give me excuses today. You requested that it cannot be conducted yesterday because you have schools. On Tuesday, I wanted to keep an extra class. You denied, but today there is holiday, there is off for everyone. There is no class in the evening. Why can we not? Let me not be a parent to you. This is how, come on, skip this. Now, this is how you write the matrix polynomial characteristic equation of A. But still, we are still clueless about S2. What is S2? Let's talk about S2 now. I hope everyone got S1. S1 is going to be what? Trace of A. Everyone got S3. What is S3? S3 is always your determinant of A. Yes or no? Sir, what is S2? S2 is going to be minor of your first row, first column plus minor of second row, second column plus minor of third row, third column. I hope you're getting it. So S2 will be here what? Minor of 1, which is this minus this. Yes or no? Yes or no, everyone. So can I directly write that value? So plus 2 minus 6. Everybody getting this? It is not cofactor. It is minor. Everyone listening and understanding. So 2 minus 6. What is that? Minus 4 plus minor of 2, 2. You already know that. I hope I don't have to explain that again. Minor we have studied in determinants. Even if you did not watch determinants, I conducted a marathon on YouTube on determinant, that backlog. Then for this 2, this is second row, second column. So 1 into minus 2, minus 0. So it is minus 2, yes or no? Then M33, this element's minor. It will be this minus this, yes or no? So minus 1 plus 2, yes or no? This is minus 2, so plus 2. So minus 1 plus 2 is what? Plus 1, correct me if I'm wrong. So S2 you have gotten as what? Minus 6 plus 1, which is minus 5, which is minus 5. So here, if I skipped writing S2, it was supposed to be minus 5. Yes or no, everyone? Good, Jagrati. Thank you so much. Don't start, making excuses like this. We cannot sit till 2. Come on. You are already writing IIT-JEE very soon. You cannot have that kind of, approach or mindset or attitude. I am doing something for you. My wife is sick today. She is lying on the bed. My daughter, 3 years old, is there and she is having high fever. She's taking care of my daughter. I wanted to cancel this session today because I was supposed to be there at home, but I told her that I'll be back in 2 to 3 hours. And if I am taking it after all those sacrifices, when my wife is sick, my daughter is supposed to be taken care by someone, my sick wife is taking care of her, and I am here taking a lecture for you all so that we can prepare for IIT-JEE. How can you say no to something really important? I planned this very important session for you, which is really crucial for your journey, which will benefit all of you. So if we are doing this much for you, why are you saying no to something like that? Why? Understand. There are always a lot of sacrifices made by us for you. So your parents, your teachers, the people who really think good of you, they really do a lot of things for you. Value them. Please value them. If you are not valuing them right now, you could be, you know, losing a lot. So first of all, plus, minus. But these signs, I hope, are coming up because of the values S1, S2, and S3. Yes or no? So everyone comfortable? How do we write a matrix polynomial or a characteristic equation for a cubic? Yes or no? Give me a quick update on that. Or shall I re-explain that? The other way could have been a minus lambda I determinant 0. You could do it and then also you could have gotten it. Yes or no? How will you do that? I'll write that all later, that other method as well for you. You will do a minus lambda I. So this is a 1 minus lambda I minus 1 0. Then 2 minus 1 minus lambda I 3. Then this is 1, then this is 2, and this is minus 2 minus lambda I. I have been understanding. You find its determinant, you will put it equal to 0. Of course, it will be a little lengthy, but when you solve this whole determinant, this is a minus lambda I have written. Everybody got this? If you solve this whole determinant, that will also give you the same equation, but it will be in lambda. And you substitute lambda by a, and then you get the same equation. Are you getting it, everyone? This is nothing but this a minus lambda I is equal to null. Yes or no, everyone? Yes or no, everyone? Give me a quick update, all the participants. Everybody with me so far? So did you get this idea? How do we write the 3 by 3 characteristic equation? How do we write the 3 by 3 matrix polynomial? Everybody able to relate it with the 2 by 2. With 2 by 2, it remained same. Trace, determinant. But the only thing got changed here was this S2 now. I hope both the short techniques you will remember. They are not short techniques. They are the rules developed by a lot of people. So this is the working rule which we have just discussed. If you ever get confused, sir, I have forgotten that short trick, I have forgotten that formula, I don't remember it. You can always stick to this idea where you do this a minus lambda I determinant 0. That will always give you. Don't have to remember any rule at all. But if you can, then please, it will save a lot of time. So I hope I can move ahead with this towards few more questions which I'm willing to discuss. So I think the previous questions of this presentation are all done. We are moving towards the next set of questions. So I'm moving towards the next few questions. Here we are. I think this question, have we done? No, we have not done. So this one question, this is another question, this is another question, third question, then this is your fourth question, and fifth question, and then 5 questions I'm supposed to do. This is something wrong, incorrect, so let me delete this. 5 questions I'm left with. Probably it will take 45 minutes, not more than that. Is that okay? So 45 more minutes I'll take. Other than that, I am done with this whole session. Are you comfortable with that? But before I start solving these 5 questions, now I'll be in a full flow. I'll be expecting the momentum from you all like that whatever I've explained so far will start getting applied now. So 5 questions, 45 minutes to 1 hour probably. It is 12:30 right now. By 1:30, I'll be closing it. Let's take a 10 minutes break first of all. At 12:30, we'll resume and we'll take it till 1:30 probably, and we're done with this chapter, with this concept, which will definitely add a lot of value in your life. 10 minutes break. Is that okay? So 10 minutes break. It is 12:25. We'll resume at 12:35. I hope everyone is okay with that. So 10 minutes break, everyone. Take a break, go for a walk, eat, drink water, and then we'll meet again. Okay, so am I clearly audible? Everyone, come back. I hope you had a good break. Now, shall we resume? Everyone, come back. Everyone, am I clearly audible, visible? All the participants, give me a quick response. Can you all hear me? Can you all see me? Everyone, come back. How many of you have done this question asked by JEE Mains? Again, very easy, very straightforward, very doable question. How do we do it? Pay attention to this. Am I clearly audible, visible? Everyone, give me a quick response. Are you all there? Give me a quick thumbs up. Everyone, are you all there? Everyone, come back. I think you had a sufficient break now. Great, good to have you all. So, alpha and beta both are real, cool. A is given by this, okay. B is given by another, this matrix, okay. Then what are we told? That they are satisfying matrix polynomial characteristic equation like this. Okay, Harini is already answering this question. Good, great, that's brilliant. And then they're asking you this expression's value. Okay, this I'll do later, but let me solve the first part of it. Is it not absolutely easy? Are you not realizing now that how easy, beautiful, simple it is if you know the characteristic equation in matrix polynomial? Right? Now, the matrix polynomial for matrix A is a square minus 4a plus 2i. Now, the moment you read it, do you not realize, I hope you remember it, this 4 here will be trace of a, yes or no? Even if I ask you something else, 2 here will be determinant of a. Same here, this 3 here will be, what? Trace of b, yes or no? And this 1 here will be what? Determinant of b. These all conclusions should be there in your mind the moment you read the characteristic equation of a 2 by 2 matrix. Everybody got that? I hope this is what you all already know. But sir, what is the point of this? What is the agenda of doing this? I am saying you that with this, can you not in a very few seconds only crack alpha and beta? You don't even have to go to this determinant. You can very easily say, sir, trace of A is 4. Trace of A is 4. So alpha should be what? 2 plus 2. Yes or no? Trace of B is 3. Trace of B is 3. So beta plus 1 is 3, which means beta here should be 2. I think my question is done. This is what I'm writing to make you understand. You don't have to do it in the examination hall. You will be directly taking them as this 2 into. Yes or no? I have got an alpha and beta both, right? Yes or no? Now, what am I asked? Sir, we are asked determinant of adjoint of a cube minus b cube. Okay. Can you help me with a square? Sir, a square is given by 4a minus 2i. Yes or no? Can you help me with b square? Sir, b square is given by 3b minus i. Correct me if I'm wrong. Yes or no? A square is 4a minus 2i. B square is 3b minus I. If I multiply it by a on both these sides, so it will be a cube 4a square minus 2i. Now, what is 4? 4 is 4. What is a square? A square is 4a minus 2i minus 2i. Correct me if I'm wrong. What did I just do? I substituted a square from here. Everyone understanding this? So this leaves you with what? 4 into 4, 16a. 4 into 2 minus 8 minus 2. That is minus 10i. Yes or no? 4 into 2 minus 8 minus 2. So this is your a cube. So instead of multiplying a with itself 3 times, I can write a cube very easily with matrix polynomial. That's the beauty of it. Are you realizing that? So this is how I'll be writing it. So a cube is going to be what? 16a. So this is a. If I multiply it by 16, what does it become? 16 into 2, 32. 16 into 2, 32. Then 16 into 1, 16. Then 16 into 2, how much is that? Again 32. This is 16a minus 10i. What is 10i? I hope you remember 10, 0, 0, 10. So this is how I'll be writing a. So, sorry, a cube. So a cube we are going to get as what? 32 minus 10, that is 22. Then 32 minus 0, that is 32. Correct me if I'm wrong. 16 minus 0, that is 16. And then what do you have next is 32 minus 10, that is again 22. That's your a cube, yes or no, everyone? Sir, it's 14a. What is 14a? What is 14a? Harini is saying 14a. What is 14a? Where did I make mistake? 4 into 4, 16a. Why will it be 14a? I will rewrite it. We were given a square as 4a minus 2i. So a cube will be 4a square minus 2i. Now a square, I'm replacing by 4a minus 2i. So 4 into 4 is 16 minus 8, 8 and 2 is 10. No, Harini, it will be 16a minus 10i. Everybody getting this? Or is there any confusion? Shall I re-explain that? I'll re-explain this if there is any confusion. I'll say this is a, and what are we told? A square minus 4a plus 2i is 0. So a square will be 4a minus 2i. So a cube will be, oh yes. Thank you so much. I missed one thing. It is 2a. I am really sorry. So I made a terrible mistake. I'm really sorry. Thank you so much, Harini, for being so vigilant and observant. And where are most of you other students? Are you not noticing that I made a mistake? Thank you so much. This is 2a, right? This is supposed to be 2a. Thank you so much. I repeat, it should be minus 4a square plus 2a. Plus 4a square minus 2, I'm really sorry. So with this, it should be rewritten as 4. What is a square? Sir, a square is this, which we have already evaluated as, I'll write it here. So this will be 4a square. So 4 into a square is 4a minus 2i, and this is minus 2a, right? This is 4a minus 2i into 4 minus 2a, right? So this is 16a minus 2a, that is 14a, and that is how much? 4 into 2, 8. Correct me if I'm wrong. So this is minus 8i. Right, everyone? I repeat, 16 minus 2 is 14, then it is 8i. Yes. Thank you so much, Dakshit and Adesh. Yes. Thank you so much, Moktika. Yes, I missed that. Thank you so much for highlighting it. So this is how you define a cube. But if I wish to write a cube in a better language, what would that be? So that will look like this, 14a minus 8i. I'll keep it as 14a minus 8i right now. Okay, is that okay? I'll keep it as this only. I'll do that whole calculation later if you are okay with that. So the next part here, which I'm supposed to do is, I'm supposed to find b cube as well. So what will be b cube? What will be b cube? Let us try and work that out. So right now I have a cube, which I'm writing with myself here. That, sir, we have found a cube as 14a minus 8i. Yes or no? Now let us talk about b cube. So to find b cube, I'll do the same thing, which means if I multiply it by b on both the sides, b cube will be 3b square minus bi. Yes or no? So I hope you're getting it. So this is 3. What is b square? B square is 3b minus I minus b. Yes or no, everyone? Yes or no? So this gives you 3 into 3, 9b minus b, that is 8b, and this is minus 3i. Yes or no? So that's b cube. Sir, we, as per the question, are supposed to figure out a cube minus b cube. Okay, let us try and work out a cube minus b cube. What would that be? Everyone listening and understanding. So a cube minus b cube, if I'm willing to write, I hope you're getting it, a cube minus b cube, that will be 14a minus 8i minus of this, which is 8b plus 3i. Yes or no? So if I now directly write a cube minus b cube, it will be this. Yes or no, all the participants? Everybody getting this comfortably now? Yes, great. Everyone with me now? So this gives you what? 14a. 14 into this, 14 into 2. 28, that is also 28, that is 14, and that is again minus 8i plus 3i. Can I directly write it as 14a minus 8b minus 5i? Are you comfortable with that? And this is 14 into 2, again 28. That is 14a. Then I'm writing minus 8b. So minus 8b will look like 8, 8, 8. And then beta is 2. So 2 into 8, that is 16. Plus 16, yes. Then minus 5i. So minus 5i, I hope I need not tell you, is 5005. Correct me if I'm wrong. Everybody got this? Or do you need further explanation of it? And with this, I think now I am finally reaching to conclude a cube minus b cube. What would that be? Everyone with me? 28 minus 8, that is 20. And 20 minus 5, that I think is 15. Yes or no? This 28 minus 8, that is 20. 20 minus 0 is 20. Correct or not? Then 14 minus 8, that is 6 minus 0 is 6. Then you have 28 minus 16 minus 5. So 16 plus 5 is 21. 28 minus 21 is what? 7. Correct me if I'm wrong. Can somebody help me with that? I hope this is what you get as AQ minus BQ. So if, let me just recheck it, 28, 8, 5. So that's 15. 28, 8, that's 20. 14, 8, 0. So that is 6. And 28, 16. And 5, 21, 7. Yes. Now, sir, can you help us in finding determinant of it? So determinant of AQ minus BQ, what would that be? 15 into 7, yes or no? That I think is 105. Yes or no? No, it's not 10. Yes, it's 105. So it is 105 minus 20 into 6. That I think is 120. Correct me if I'm wrong. So this is your 120 here. So that leaves you with a minus 15. So determinant of this we have got it. Let me call it C for a while just to make you understand this. AQ minus BQ I'm calling as C for a while, just to make you understand this. So to help me with this data here, what are we given? We are asked determinant of adjoint of C whole square, yes or no? This AQ minus BQ is nothing but what here? C. So adjoint of C's determinant square is what we are supposed to figure out. I hope you remember this property that we have already discussed. Determinant of adjoint of A is determinant of A to the power n minus 1, I think. Yes or no? Everyone remember that property? Are you all there, listening and watching and understanding? With this, adjoint of C will be determinant of C to the power 2 minus 1 because it is 2. The order is 2. 2 minus 1 is 1. So that is 1 already there. So I don't have to write it. And that 1 is raised to the power 2. So it leaves me with a 2 here. Yes or no? So this is minus 15 square, which of course is going to be 225. And I'm sure most of you must have marked 225. Did we conduct a poll here? We didn't, unfortunately. But I hope most of you got this. How many of you got 225 is the answer? Muskan, Dakshit, who else got this? Harini, I think, has also got a 225. Everybody, all the participants. Did you all get this? Did you all understand this? Shall I move ahead from here? Everyone. Now, with that, let us move towards the next question. This again is something absolutely simple, absolutely straightforward. This is not a mains PYQ. This is simply a question which I have kept. And this one, I'd like to give you as a homework question. Is that okay if I do so? So this is simply a question I'm keeping here. So this is just a question. This is not a PYQ, of course. So this one, if I give you as a homework, shall I tell you the hint or can you do that by yourself? I hope you know for a 2 by 2, you know how to write it. Everyone, be very quick. It will be given by a square minus trace of it, which is 4, plus determinant of it. So 3 minus 2, that is 1. So 1 into identity matrix, that is how you got its characteristic equation. So by comparing it, A will be minus 4 and B will be, of course, 1. Although you don't have to do it, you know that it will be what? Trace, and this will be determinant. So that also gives you the final value here. Have you all gotten this? Have you gotten this? But of course, take care of the signs, plus, minus, plus. So that should also be considered here with A and B. Now, I'm asked to find A inverse. I hope you know how to find A inverse. A square will be, I here will be given by 4A minus A square, yes or no? This 4A minus A square, yes or no? So A inverse here will be 4A inverse, which is 4I, minus A square into A inverse, which is A. So from here, can you not tell me A inverse? Are you all good at that, or shall I do it? I hope you are comfortably getting it. A inverse will be 4I, which is 4, 0, 0, 4, minus A. What is A? Sir, A is 3, 1, 2, 1. And that gives you the final answer as 4 minus 3, 1, 0 minus 1, minus 1, 0 minus 2, minus 2, and 4 minus 1, that's 3. Sir, do you not think we could have gotten the inverse by simply finding using that adjoint shortcut for a 2 by 2? That also is a doable approach, which you already know. But I was willing to discuss this matrix polynomial characteristic here. That's good, Krupa. Mod A plus mod B will be 5. So that will be 5. I hope no confusion on that. So I think we have gotten all the answers. We have found, I think, all the answers. Everybody understood that? Shall I move towards the next question? This again is a good one. How do we solve this? Let's talk about that. A very interesting one. Now, when you look at its matrix polynomial, how does it look like? It is A cube minus 4A square plus A plus 21I is equal to null matrix. Yes or no? Yes or no? I hope you remember that for a cubic, a 3 by 3, we write it as a cube minus s1a square plus s2a plus s3i is equal to null matrix. Where what are these? I hope you remember. S1 is your trace of A. Do you remember that? S2 is your sum of the minors of the principal diagonal elements. And what is S3 here? S3 is your determinant of A. Do you remember that? So even if you don't use this S2, you will get the answer to this question by using these two values only. Everyone listening and understanding? First of all, I think A and B is what we are interested in asking us to figure out. So trace of A. Trace of A, are you not thinking is 4 here in this case? Trace of A is 4, which means 2 plus 3 plus B should be 4. Should it not be? So this gives you 4 minus 5. So we receive B as minus 1. Give me a quick update on this. Everybody understood that? Or shall I re-explain that? Everyone with me on this. Sir, what else? I think I know determinant of A as well. Determinant of A we have evaluated as 21. So determinant of A should be 21. So if determinant of A is supposed to be 21, I think that gives you the next answer here, which is the value of A. I hope you're comfortably getting it. Determinant of A we know is 21. Determinant of A we know is 21. So I have two values. Determinant of A is 21 and B we know is minus 1. So I think I'll simply expand it. Everyone realizing that? Everyone getting it? Everyone. So with this here, let me start a poll as well so that we can see how many of you are getting it genuinely. Here we are. So determinant of A. So this is 2A0. Then you have 1, 3, 1. Then you have 0, 5B. But what is B? Minus 1. Then again 2A0. Then 1, 3, 1. And this is supposed to be 21, right? So there if I start expanding it, I'll see 2, 3 minus 1. That is minus 6. 0 and 0. Yes or no? 0. This is 10. Yes or no? And this is, of course, minus A, but minus of minus A is plus A, and this is supposed to be 21. Correct me if I'm wrong. So with this, minus 16 goes to the other side is plus 16. 21 plus 16. 21 plus 16, I did not tell you, is clearly 37. So A we receive as 37. So this is 2 into 37 plus 3 into B, which is minus 3. Did I make any mistake again? Because this is not what is matching here. I think there is something wrong here in this question. Let me recheck first of all this, then we'll do the correction here. 2A0, 131. Why am I making so many mistakes? 0, 5B, B is minus 1. Then again 2A0, 131. So 2, 3 minus 1 is minus 6. 150 is 0. 0A1 is 0. Then you have 0. Then you have 10, which is minus 10. Then you have plus A. So this is good. Minus 16 plus A. 21 plus 16 is what? 37. Right? That is 37. So if it is 37, A is 37. And I think B was minus 1. B was supposed to be minus 1 because how did we find B? B was basically found through trace. Trace is 4 because it is minus 4. So I hope you're realizing it is supposed to be minus 1. So yes, it was good. It was great. A will be minus 5. Why? Oh, no, it's correct. It's absolutely correct. Oh, yes. No, it is correct. It is still correct. Everything is plus, minus, plus. Oh, yes, I'm making a mistake. I am really sorry. Thank you so much for making that correction here. It is minus here. I'm really sorry. So determinant of A. Yes, thank you so much for that correction. It is minus 21. I hope you remember that. Thank you so much for highlighting it. Harini, Jagrati, that's good. Thank you so much. Plus, minus, plus, minus. I mistakenly took it as plus. I'm really sorry for that, but I hope you realize it now. It is minus. So S3 here, I hope you're understanding. Minus of S3 is 21. So S3 will be minus 21. What is S3? Your determinant of A. Everyone understood that, or shall I re-explain this part? So if this is minus 21, there is a small correction here. This is supposed to be minus 21 here, and with that minus 21 plus 16 will give you a minus 5 here. So we'll get the final answer. 2 into minus 5 and then 3 into B. So 3 into plus 3 into B, which is minus 1. So I think minus 10, minus 3, minus 13. Yes or no? So I hope most of you must have gotten minus 13. Minus 13 means option C. So good, Kripa, Harini, Dakshit, Jagrati, Kaulik and Sanjana, all the participants, are you all understanding this? Have you all gotten a decent clarity on this? Shall I move ahead from here? Now, let us move towards the next question for the day. What does it say? Here we are with the next few questions, last two questions. Very good questions, one of the best questions. If you solve this, you are done with this chapter. Trust me. How do we do this? Before I start this, of course, we'll be conducting a poll in this question. So timeless poll. Let's start now. Look at the question. It gives you this is A and this is P. Whenever somebody gives you P in this manner, try to remember it. Try to memorize this result. Why? Because look at this P. Forget the whole question. Look at this P. P is given by cos theta minus sine theta, cos theta. Yes or no? Can you help me in multiplying P with its transpose? So if I multiply P with its transpose, this Cn minus S will become the first column and S and C will become the second column. Yes or no? Now matrix multiplication you all know, you all are good at. So PPT I'll be working out as, I hope, rows I'll choose from here, columns I'll choose from here. So C minus S, cos square theta plus sine square theta is 1. CS minus SC, that is 0. Then this row with this column, sine, cos sine, but with negative, it is 0. Sine square theta plus cos square theta is 1. So I got P into P transpose as an identity matrix. So P here is your orthogonal matrix. P here is your what? Orthogonal matrix. I hope everybody knows that. Orthogonal means P when multiplied to its transpose will give you an identity matrix. Everybody remember that? So I am requesting you to remember it as a general result. Which general result? That the moment you see this matrix here, then please don't invest your time in figuring out this. C minus S SC will always be orthogonal. Sir, what do we mean by that? Let's say here instead of theta, they put some other value. I'm just giving you an example here. Let's say instead of theta, let's say they give you a matrix X. So there instead of theta, let's say they give you 30 degree. So 30 degree means what? Cos 30 is root 3 by 2. Minus sine 30 is what? 1 by 2. This is again sine 30, which is 1 by 2. And this is cos 30, which is what? Root 3 by 2. So let's say someday I'm given this matrix X. I'm given this matrix X. And if I could realize that this is cos theta minus sine theta and cos theta, I won't be wasting my time and I'll be concluding that X is a orthogonal matrix. And if X is an orthogonal matrix, I will be using its results directly. Will you remember this pattern first of all? Tell me honestly. Now, let's get back to this question. This was something else which you're supposed to remember and memorize. Now, what do I mean by this result which I am discussing right now here with you all is this, that first of all, I have concluded that P is an orthogonal matrix, which you all now understand it pretty well. Do you remember it? We had a discussion on this, all the participants. Now, if I have this conclusion in mind, sir, how is it going to be useful in this question? Let's talk about that. So here we are told B is PAPT. What is C? C is PT, B to the power 10P. That's good, Jagrati, Adesh. That's brilliant, students. So let's define C. Sir, C is P transpose. It is starting with P transpose, it is ending with P. But what is B to the power 10? B to the power 10 means B repeated 10 times. What is B? Sir, PAPT, 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 PAPT. How many times? Sir, 10 times. Yes or no? This is written 10 times. This particular part is written how many times? This is what is written 10 times. Yes or no? Are you able to visualize this in your brain? You don't have to do this, but I'm just giving it to you so that you don't get confused. What is C? PT, P, and in between B to the power 10. What is B to the power 10? PAPT 10 times. Sir, we know P is an orthogonal matrix, which means PPT you do or PTP you do, it will be an identity matrix. It will be an identity because P and PT are inverse of each other. Yes or no? That means PTP, 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 all these PTP will be what? Identity matrix. So this is A multiplied by a lot of I's. Order I'm not concerned about because I with A, whatever order you take will be A. But this A is turning out 10 times. So is it not simply A to the power 10? So my whole question boils down to the simple fact that if you crack this P here, you will be calling that this P is nothing but A to the power 10. Sorry, it's not P. If you crack this B here, sorry, C here, so this C is nothing, but it's simply a to the power 10. A very, very simple, straightforward, doable question so far. Now what? I think the job is done. The job is absolutely done. Are we not done with the question, students? Can somebody quickly tell me what is going to be the answer here? We are asked the sum of the diagonal elements of C. Come on, you tell me what is needed to be done. Have we not invested our time in learning eigenvalues and its properties? And if we know that, we know the answer. I hope you remember, let's say the eigenvalues of A here. What are the eigenvalues of A here? I hope you remember the eigenvalues of A here are going to be, I can find out it. But always remember, I'm telling you one more interesting fact here. Please remember it as a general result. Please remember it as a general result that if you ever see a triangular matrix, triangular matrix means upper triangular or lower triangular or a diagonal matrix. Let's say this is a matrix A, B, C, but there is a 0 here, upper triangular, or you see, let's say M, N, P, but there is a 0 here, or you see, let's say K and L, but zeros on non-diagonal elements. So let's say you see upper triangular, lower triangular, or diagonal. You'll always remember for these matrices, the eigenvalues are always the diagonal elements. The eigenvalues are always the diagonal elements. Are you getting my statement, everyone? So for upper triangular or lower triangular matrix, or for triangular matrices, the eigenvalues are always the diagonal elements. The eigenvalues are always the diagonal elements. Will you remember that as a fact? What I said was that for any triangular matrix, the eigenvalues are always the diagonal values. Did you get that? Sir, what do you mean by that information here in this question? I hope most of you must have already realized that why am I giving you that information here in this question. Has anyone noticed that? Has anyone noticed that? I hope you are seeing, if I ask you the eigenvalues of A, is it not an upper triangular matrix? And if it is an upper triangular matrix, eigenvalues of A are going to be 1 by root 2 and 1. Yes or no? Sir, we didn't know this property. How are we going to use it? Okay, you don't know this property. You create the matrix polynomial for A. You solve that quadratic. You will find two roots. Those two roots will be 1 by root 2 and 1 only. Are you able to understand that statement now with more ease? Yes or no? Yes or no, everyone? Now, sir, what are we supposed to do next? Your job is done. Why? Because this is eigenvalues of A. Sir, what are we asked? We are asked sum of the diagonal elements of C. I repeat, we are asked trace of C. That means we are asked trace of A to the power 10. Sir, can somebody quickly tell me what will be the trace of A to the power 10? Trace of any matrix is sum of its eigenvalues. But sir, we don't know the eigenvalues of A to the power 10, but I think you know the eigenvalues of A. If you know the eigenvalues of A, don't you know the eigenvalues of A to the power 10? Did we not discuss that property? Eigenvalues of A to the power 10 will be 1 by root 2 to the power 10 plus 1 to the power 10. Yes or no? Yes or no, everyone? And 2 to the power 5 it will be, I think it's 32. So it will be 1 by 32 plus I think 1. So it should be 33 by 32. So the answer they are saying is 33 by 32, but they are asking you, they are clearly co-prime. So m plus n, 33 plus 32, I think is 65. Option D. I think nothing else is asked. Nothing else is asked. How many of you genuinely did it by yourself? How many of you got this conclusion by yourself? That's unbelievable, Krupa. Again, 2 seconds you took. Unbelievable. Kaulik, Nagalakshmi, Jagrati, Adesh, Sanjana, Harini. That's good. What about these kids who got A and B? What went wrong? Okay, everybody understood this solution. Everybody got the logic here in this question. Did you all get this? Did you all understand the whole solution? Can I move ahead from here, all the participants? Everybody with me on this? every single step. This is a very beautiful question, which is giving you a lot of insights of all what we have discussed so far. So this can be treated as a summary of what we have done so far. Final question for the day, you tell me, shall I get it done or shall I give you this as a homework? Shall I not give you this as a homework, because this is exactly what we have done in the previous question. This is exactly what we have done in the previous question. Have we not done that? So, sir, still you're supposed to give us the hint. I will, but I'll try to stop myself from solving it. So, hint, if I could give you, look at this P, look at this P, and look at what I have just told you, I think, few moments ago. Look at just what I have told you few moments ago. This is not a new kind of question, Jagrati. This is that same question only. Notice the details. I hope you're realizing cos, sine, cos. I hope you're noticing. I hope you're noticing. This P is going to be that again orthogonal matrix. If you don't believe me, check it out by yourself. Check it out by yourself. This is actually that PT there. So this PT into P will again be identity. So I think your job will be done. Once you check whether P is orthogonal or not, your job will be done. And trust me, they'll give you it in that manner only that your question becomes absolutely easy here. Because what is Q? This is P A P T. So again, P, PT, PT, P, that will all become identity. That all, okay, great, Jagrati, that's good. No. Even these huge powers, when are considered, this is all becoming identity. That's how they confuse you. And if you, let's say, if you don't do this, let's say you are interested more in finding higher powers here. Let's say if you start finding the pattern, that also you can do. But I'll say use that method. Ultimately, there is one more method you'll be using here. First of all, you'll crack this. So once you crack this, I hope you'll realize that you can crack this PTQ 2000 Q to the power 2007P. But what will be it? I hope you're realizing it will be a to the power 2007, because all these PTP will become identity matrices. Yes or no? The way we did it in the previous question. The same will happen here. So technically, this whole expression will be leading you towards a to the power 2007. Now, sir, how do we crack a to the power 2007? How do we crack a to the power 2007? Do you not know? Again, we did discuss two or rather three methods. What are those three methods? First method, I hope you remember, you simply start finding it a into a, that's you find a square, then you find a cube, then you find a to the power 4, and that's how you start seeing a pattern and you generalize a to the power n. Second method, sir, we write a as m plus I, and then you apply binomial expansion. Do you remember that? That is, trust me, more easier. Then third method, you write the characteristic equation of a. Characteristic equation of a will be a square minus 2a plus determinant of a, which is 1 minus 0, that is 1, that is this. And with this also you can generalize higher powers of a. This is a square, then you can find a cube, a to the power 4, and so on. So these are the three methods through which you can generalize a to the power n. Once you are done with generalization of a to the power n, I think this will be nothing but a to the power n only, which is a to the power 2007. And by comparing those values, which will get the final answer, you will get this answer. Tell me honestly, if you really want me to solve this, I can do this. But if you want to try it by yourself, you can also do it. Sir, it is orthogonal matrix. That's good, Adesh. Do you want me to do this? I have already given you the hint. If you want me, I can. I will definitely do it for you all, because that is the final question for or of the chapter Matrices and Determinants. And I could not resist myself from doing it, because I want you all to understand it thoroughly, clearly, and absolutely clearly. No, sir, will do. So I will do it. Okay, you will do it. Great. So first of all, shall I assume this is P? What is P? If I take it here, this is root 3 by 2. Root 3 by 2 means what? Can I take it as cos 30? Cos 30 I'm writing as theta. I'm taking theta as 30. Is that okay? This is 1 by 2, which means it is what? Sin theta. Yes or no? What is it? It is minus sin theta. Yes or no? What is it? It is again cos theta. Theta I'm taking as 30, but I hope you're okay with this theta as well. What will be PT? I hope you're realizing PT will be nothing but what? Cos theta minus sin theta. This will be then sin theta and then cos theta. Sir, this is same as previous question only, yes or no? In previous question, this was P and this was PT. But PT into P was I, then PT into P will also be I, because P and PT are inverse of each other. So first of all, PT into P will be I. I got this conclusion that PPT will be I, which means I conclude this, that P is your orthogonal. Although you don't have to write all of this, I'm just giving you this idea here. Then what do we do next? I think we solve it further. How? Let's talk about the next conclusion. What is the next conclusion here, students? The next conclusion is we got this PPT is I. That is what we know. Because P is orthogonal. P is orthogonal. That is what you have already seen. Now, what is Q? This is Q. So PT, PQ to the 2007 into P will be PT. Q is what? This. So PAPT, I am writing how many times? PAPT, I am writing how many times? PAPT, I am writing how many times? Students, tell me. I am writing it 2007 times. Yes or no, everyone? Yes or no, everyone? With this, I hope you're realizing PTP, there'll be I. So A is written 2007 times. So technically, I am simply boiling down my problem to simplifying A to the power 2007. Yes or no? Yes or no, everyone? So now I need to crack A to the power 2007. So if I want to have this, I think I can generalize it with a lot of multiple results. So I'm just using one of the methods here. Let me write the matrix polynomial for A, right? Or rather A as a sum of two matrices where M plus I. What is I? Sir, I is 1, 0, 0, 1. So what is M? It will be 1, which means 0. This will be 1. This will be 0. This will be 0. Yes or no? Yes or no? Now, can you help me in cracking A square? Sir, A square will be what? I hope you're understanding. This is how I'm writing it as. I hope you remember this method. This is your M and this is your I, right? 1, 1, 0, 1, right? So I am willing to find out M square. Can you help me with M square? M square here is going to be what? 0, 1, 0, 0 multiplied with 0, 1, 0, 0. Can you help me in M square? M square is going to be what? 0, 1, 0, 0, that's 0. 0, 1, 1, 0, that's 0. 0, 0, 0, 0, that's 0. 0, 0, 1, 0, that is again 0. Yes or no? So M square is 0. M square is null. So I think my job is really simple now. If I ask you A to the power n, which means M plus I, or rather I'll say I plus M to the power n, will you not say by binomial expansion it will be I plus nm, then nm minus n minus 1 by 2 m square, but m square is null, so all the higher terms will be this. So I am in a position to generalize this. How many of you got this? Do you remember we did discuss this method? Do you remember we did discuss this whole method? So with this, I think I do have the answer finally, because I'm interested in a to the power 2027. So a to the power 2027 is going to be what? I plus nm. I is I, which is 1, 0, 0, 1, plus n, which is 2027 into m. What is m? M is 1, 0, 1, 0, 0. So can I multiply it inside? It will be 0, 2027, and then 0, 0. So finally, this is your a to the power 2027. What is that? What is that? What is that, students? What is that? Can you help me with the final answer? I think you do have the final answer at your fingertips now, don't you? I hope you all have cracked this answer by now. Yes or no, everyone? So finally, this a to the power 2027, which is this only, is going to be 1, 2027. Although you don't have to do all of this, but I'm just writing all of this so that you don't get confused. So by that, I think a is 1. So 2a will be 2 plus b. b is 2027 minus 3c. c is 0. So this is 0 minus 4d. So d is 1. So this is 4. So this is minus 2. So 2025. Oh my God. Did I make any? It is not 2027, right? I'm really sorry. I'm really sorry. So this is a to the power 2007. So this is also 2007. I'm really sorry. So that kind of mistakes I usually commit. Please, you don't commit. I can afford to commit because I'm not going to write this exam, but you shouldn't, right? I mistakenly took it as 2027. So this should also be 2007. So this should be 2005, which is option B. Everybody got this. Thank you. Thank you. Thank you, Harry. Why is it 2000? Okay. Now, I think I am done with this chapter. So if I could give you the summary, we started with matrices. So I hope you know how are they different from determinants, first of all. Then we did discuss different types of matrices. I hope you know all those types. Then we talked about different operations and we talked about product of matrices. Please don't forget that. Then I kept on discussing different types of matrices, skew, symmetric, symmetric, transpose, and a lot of things, operations we did discuss. And then eventually I shifted to three major things: adjoint, inverse, and then finally matrix polynomial, which is the major chunk or the more important chunk of this chapter. So far, this is what we have discussed, and we are done with this chapter with all of this. Now, what is my expectation from you all now? You will download this PDF, you will keep these notes saved with you, and then you revise. These PDFs means all the PDFs of this entire chapter memorizes. But from today's session, what you're supposed to do is go through all the questions. The easier ones, you don't need to solve them, just look at them. Moderate and tougher ones, you are supposed to solve by yourself. And tougher ones, you can mark there so that when you're revising the notes, you don't have to go through the whole theory, whole questions, all questions. You just revise the tougher questions only. After this, I'll suggest you to go with the DPPs now. Start solving DPPs, the DPP which you might have gotten. I think with today's session, you may not. So the previous one you can solve, because that I think you haven't solved yet, because that was based on matrix polynomial, characteristic equation. Then what you're supposed to do, by now, I am sure you are done with the PYQs of determinants. So since now chapter matrices we are done with, so now you can start solving PYQs of matrices, because from tomorrow onwards, I'll be starting the next chapter, relations and functions, which is again a very important chapter, and it lays the foundation for calculus, the king of mathematics. 50-60% of your syllabus is asked from calculus in mains and advanced both. And the whole foundation gets laid with this chapter, relations and functions. Everybody got the whole idea? Shall we call it a day here? You got your job, what you're supposed to do. Any other queries or confusion if you have, please ask. Otherwise, I'm done with this chapter. And thank you so much for being so patient and learning and understanding all of this. Can we call it a day, everyone? Any other queries or concerns you have, please ask. I'll be really happy in addressing them. I know you all are tired, but thank you so much for you all being there. Great, great, great. Good to have you all. Any other queries or concerns? Tell me. Is there anyone left, or am I the only alone one? Kaulik, Krupa, Jagrati. Okay, great. Archana, great. So good to have you all. I really appreciate that. Despite being it a holiday, you all turned up. Thank you so much. Good, Harini. Good to have you all. Good day, everyone. Take care. Okay, Dakshit. Thank you so much, Kripa, for being so considerate. Thank you. Desh, just study what is being told. Your teacher knows a lot. Trust me. Have faith in your trainer.